Dear students, today we are going to discuss one of the important topics, that is thermodynamics. Okay, so let us see in this thermodynamics what are the things you have to remember. One is zeroth law of thermodynamics, first law of thermodynamics, and different types of process. So isothermal, adiabatic, isochoric, isobaric, all these process you have to discuss about the work done and the amount of heat required to raise its temperature, right? So let us see in this zeroth law of thermodynamics, that is so the simple only, but we concentrate mostly on second law of thermodynamics. I mean, so first law of thermodynamics. So which is most important, and most of the questions they ask in first law of thermodynamics, right? Now let us see. So in this first law of thermodynamics, so then amount of heat required or amount of heat given to the system. Let us take what one system is given. So the amount of heat given to the system is dq. And if the amount of heat is given to the system, so its internal energy changes and as well as what? Work done. So that's why whatever the amount of heat is given to the system is utilized to increase its internal energy and also to do external work done. According to the first law of thermodynamics, so the this energy is conserved. Whatever the amount of heat is given to the system, so part of the amount of heat is utilized to increase its internal energy and the remaining energy is utilized to do external work. So dq is equals to du plus dw. Okay, right. Now, so this one is, and one more, if the amount of heat is given to the system, should be taken as what? Positive. dq should be taken as positive. If amount of heat is, this one is taken out from the system, dq should be taken as negative. And also if the temperature increases, du is taken as positive and temperature decreases, it is so negative we take. And work done by the gas to be taken as positive, work done so on the gas, so it taken as negative. Okay, these are the sign convention should be taken. Now, so let us take what dq is equals to u final minus u initial, also can be written as this dw. Okay, this is first law of thermodynamics. And one more, the most important, based on this only, this 2026 question asked. Let us see one example. So this is 2026. This question is 2026 asked based on first law of thermodynamics. Let us take, so how they asked, let us see, dq is equals to du plus dw and the rate of work done. Okay, if I take what rate, if I take but by time, and also du by dt plus dw by dt. Okay, right. So rate of the amount of heat so given to the system, that is given as what? Supply heat is given. So what is given? What is nothing but energy by time or joule per second, or dq by dt is given as 100. So which is nothing but joule per second or watt. So, and also this system performs work at the rate of, this is, so work at the rate of by time, that is 75. So then is asking about then the rate at which internal energy increases. Rate is nothing but so by time. So rate of internal energy is nothing but du by dt, which is equal to, this is du by dt, or du by dt is equals to 100 minus 75, which should be equal to 25 joule per second, or we can write it as what? 25 watts. This question asked in 2026. Okay, right, based on first law of thermodynamics. That's why this is very important. Now, and also we can take one important thing I'll discuss. dq is equals to du plus dw. Okay, so the amount of heat is given to the system. For example, if I'm taking, so I'll change the color, right? This one. So let us take what dq this is. And the part of the energy utilized to increase its internal energy du, and the remaining energy is to do the external work done. For example, if I give what 80 joules amount of heat is supplied to the system. So 20 joules utilized to increase its internal energy, and the remaining energy is 60 joules. Let us take. So it is this is what the 60 joules is the work done. So 80 joules is given, or you can take it as what calories. 80 calories if you take, 20 calories is utilized to increase its internal energy, and the remaining energy, that is 60 calories. For example, you can take what calories. You take what all are in calories, all are in joules. Right. So let us take what 80 joules. If I am taking 20 joules utilized to increase its internal energy, and the remaining energy 60. So to do the external work done. For example, if I am saying, so what fraction of internal energy is taking place out of 20 joules? So this is what out of 80. How much increase in internal energy? 20. Therefore, 20 by 80. This we call it as what? So this is du by, we can write it as what? dq. dq is 80 and du is 20. So fractional increase in internal energy, we can write it as what? du by dq. Okay, then I can take it as what? du by dq. We can write it as what? It is fraction is 1 by 4. Then we can write it as one very important so formula. We can write du is equals to, we can write, so increase in internal energy takes place so at constant volume, and dq is equals to ncp dt. Whenever at constant pressure, the amount of heat is given to the system is utilized to increase its internal energy and also to do the external work done. Therefore, N cancel dt, Cv by Cp is equal to, we know that ratio of specific heat, we can take it as, so this is gamma, or this Cv by Cp, we can write it as what? 1 by gamma. Now we can write one important, so this one important formula is, you have to remember, du by dq is fractional increase in internal energy. Du by dq is 1 by gamma. This is one very important. And dw by dq is equal to 1 minus 1 by gamma, we can. Okay, so these are very important. You have to remember, this is the first one, second one, and also this is third one, and this one is the fourth one. So what you have to remember, whenever fractional increase in internal energy, which is 1 by gamma, if I ask percentage of increase in internal energy into 100, or this in percentage of work done, we can take it as what? 1 minus 1 by gamma into 100 we can. So like that, so these are the four formulas must have to remember, very, very important. And also, so I'll change the color and I'll write, look at here. So for example, so this one is what? du is to dw is to dq. One more very important, this is the fifth one. So by q dq, and if I'm dividing by dq, what you can get? Let us take what? du by dq is 1 by gamma is to 1 minus 1 by gamma is to 1. So like this we can take, it is a ratio of, we can write as what? du by dq is to dw by dq, and also dq by dq we can. Okay, even this is also you have to remember as the fifth one. Okay, so this first law of thermodynamics must have to remember these 4 points. One is what? dq is equal to du plus dw. D is what? Increase, change in, internal energy, and also du by dq is 1 by gamma, dw by dq is 1 minus 1 by gamma, and the ratio of, so du by dq, dw by dq, dq by dq is, we can take what? Like this. And also one very important I can give, what about the expression for du? So internal energy takes place at constant volume, du is equal to ncv dt, and also dq. So whenever at constant pressure, if the amount of heat is supplied at constant pressure, we can take it as what? ncp into dt we can. Okay, so we, before going to discuss what another question, so let us see these things. Right. So one more. So one point you have to remember in this. Let us take one point I'll give. So then, so for example, based on the previous things what I gave, based on that one, and before going to discuss this question, so you have to remember. So du, the expression for du, internal energy takes place at constant volume. The important things you have to remember. So for du expression, du is equal to ncv dt, or n into r by gamma minus 1 into dt, or nr into t2 minus t1 by gamma minus 1, or P2 V2 minus P1 V1 by gamma minus 1. This is what very important as far as so increase in internal energy. du is equal to ncv dt, nr dt by gamma minus 1, or nr into T2 minus T1 by gamma minus 1, and P2 V2 minus P1 V1 by gamma minus 1. Okay, this is the expression for du. And also, what about dq expression? So dq expression, suppose if it takes place at constant pressure. Okay, so the amount of heat supplied at a constant pressure, then whenever they ask what constant pressure, then dq is equal to ncp dt. Okay, suppose if you don't know about constant pressure, nc into dt, where c is so specific heat of that particular process we can. But generally particular process c is equal to, we can take it as what, cv plus r by 1 minus m, when pv to the power of m is constant. Or we can write it as r by gamma minus 1 plus r by 1 minus m we can take. So pv to the power of m is constant. Then, so for different process, there are different process we have: isothermal, adiabatic, isochoric, isobaric, okay, and the polytropic also. Okay, the different process we have. And one more very important thing you have to remember. So a gas can have how many specificates? So most of the students, they think that, so that is what one is specificated constant volume. Another one is what they think that what specificated constant pressure. A gas can have what only two specificates. So this one is what think, but it is wrong. A gas can have infinite number of specificates. Okay, so this point you have to remember. A gas can have what infinite number of specificate, but Cp, Cv is what in the two process at constant pressure is Cp, and also constant volume is Cv. Okay, these points you have to remember, right? So for any type of process, so then C is equal to Cv plus R by 1 minus m, where Pv to the power of m is constant. Some questions we discuss based on this one, then only you can understand well. So now another important, then what about dW? dW will discuss what afterwards. First we'll discuss this question. After that we discuss about dW for different process we'll discuss. Okay, right. Now let us see. So now this question we'll discuss. A diatomic gas gamma is equal to 1.4 does 200 joules of work when it expands isobarically. Okay, isobarically means what? At constant pressure. Isobaric means what? Constant pressure. Isochoric means what? It is constant volume. Isothermal is what? Temperature is constant. So that's adiabatic is amount of heat is constant. Okay, so now let us come to this one. As I told previously, that is what is given here. This one, a diatomic gas does 200 joules of work. dW is given as 200 joules is given, and also gamma is given. Gamma is equal to 1.4, and is asking this is barically. Whenever amount of heat is given isobarically, the amount of heat is utilized to increase its internal energy as well as to do external work done. So that's why what you have to take is asking heat given to the gas is. What about dq? As I told in the previous slide, so what I gave, so that is dW by dq. What I gave, just tell me. dW by dq is equals, I gave du by dq is equals to 1 by gamma, whereas dW by dq is equals to 1 minus 1 by gamma. Okay, right. dW by dq is equals to 1 minus 1 by gamma, but he's asking about dq. dq is equal to dW by 1 minus 1 by gamma, which is equal to dW. But what is dW is given? 200 by 1 minus, what is gamma? What type of this one? Gamma is given as what? 1.4. You have to remember. So what are the things you have to remember? For monoatomic gas, gamma is equal to 5 by 3. For diatomic gas, gamma is equals to, this one is what? 7 by 5, which is equal to 1.4. Okay, diatomic gas. And also, these about what? Triatomic. Tri or, so this one what? Polyatomic gas. Tri or polyatomic gas. Polyatomic gas, let us take what it is, what? Non-linear. Okay, for non-linear, gamma is equals to what we can write 4 by 3, which should be equal to 1.33. And gamma, diatomic gas, gamma is equal to 7 by 5, which is equal to 1.4. Or, so we can say what the diol, so this one is what polyatomic gas or triatomic gas. So we can take per linear. So, okay, so either it is what linear, we can take it as what it is. Gamma is equals to 1.4. So we can say, so this is what for linear. Linear means what? One rotational kinetic energy gets cancelled. We get in this. So that is in degree of freedom we discuss. That is about what linear. So this one tri or polyatomic non-linear, we can say it is gamma is equal to 4 by 3. And diatomic or linear, we can take it as what 7 by 5. Now we come to our question. Then gamma is clearly it is given 1.4. Need not to. So this remember because directly it is given there. So then dq is equals to 200 by 1.4 minus 1 is what 0.4. We can take what by 1.4 we can take that 4 cancel. Then 200 into 14 by 4, which should be equal to 50. 14 5 is 70. 700. So this is what joules. Therefore, the correct answer is 700 joules. That way you have to remember. Understood? So you have to remember in this what to be remembered. dw by dq is equal to 1 minus 1 by gamma. And whereas what du by dq is equals to 1 by gamma. And for monoatomic gas, if it is given, you can take. Otherwise, suppose if it is given. So this one is what gamma they may give or may not. Simply they say what diatomic. As it is what given diatomic, you can take it as what 1.4 or 7 by 5. So, but diatomic or triatomic linear, you can take it as what gamma as 7 by 5 only. So, polyatomic gas and also non-linear, we can take it as what, so this one is what, polyatomic tri or polyatomic gas, we can take it as what 4 by 3, that is equal to 1.33. Okay, so this one, then we go to what, before go to the next question, so let us see these things. Right. Now, let us come to, so another one you have to remember. Then let us come to another question. See, yes. Now, let us come to this one is also based on first law of thermodynamics. Now, one more important point you have to remember. So in cyclic process, whenever they say what cyclic process, so cyclic process, what you have to take this word cyclic, it comes toward the same position. That's why initial positions and final positions are same. In cyclic process, du becomes what 0. Okay. And also whenever they say what free expansion, whenever they say free expansion, du 0, dq 0, and also dw 0. In free expansion, should have to remember dq 0, du 0, dw 0, and also in cyclic process, which is comes towards same position, because you know du is equal to p2 v2 minus p1 v1 by gamma minus 1, just now I gave. And because initial and final positions are same, as initial and finals are same, you can take it as what p2 v2 p1 v1 is same. That's why du becomes what 0. Whenever in the question asked, so this is the cyclic process, you can take what du is 0. Okay, right. Those things you have to remember. Now, before going to discuss these things now, and also free expansion, as I told already, should have to remember dq, du, dw 0. Right. Now come to this question. To a system, 300 joules of heat is given and it does 200. Let us take what first law of thermodynamics. dq is equal to du plus dw. System 300 joules of heat given. So you must have to remember, you should be careful about the units. Sometimes they give what calories, sometimes they give what joules. So let us take what, because it is given, so both are in joules and answer is also asking in joules. Sometimes this is they give what joules and this one they give what in calories. You have to convert into. So this one according to the answer. If the answer is given joule, one is joule, one is calories given. This calories you have to convert into joule, then you have to do the question, right? Now, dq is equal to du plus dw. System 300 joules of heat is given. So as it is what given, so given to the system means what it is what plus, and also du is asking about du plus what about the work done and does 60 joules of work. It is doing what 60 joules of work. Therefore, du is equal to 300 minus 60, which should be equal to 240 joules. So system is doing work. That's why it is what plus 60, and heat is given to the system. So as the heat is given to the system, it is what plus 300 minus 60, which gives rise to 240 joules, because all are given in joule. So your answer also should be given. So you get also in joules. Okay, these things should have to remember. Once you just see this one, so then we go to the next question. Right. Next one, another important question we'll discuss. Let us see another one. So now let us come to this question. Let us see. And one more, so important should have to remember, there are different process we have: isothermal, adiabatic, isochoric, isobaric. These things you have. One thing you have to remember. So let us take, before we discuss this question, so let us take, so one thing is what isobaric. First, I want to discuss what these things. First, after discussion of these important things, we go to this question. Right. In isobaric process, what are the things you have to remember? Pressure is constant. Okay. And also, which one is zero? So dq is not zero. dq, du, dw present, or dq is equal to du plus dw. Okay, right. Now, so what about the DW, isobaric process? So isobaric process, pressure is constant, P into V2 minus V1, or PV is equal to nRT, or nR into T2 minus T1. This is what work done in isobaric process. Okay, so these things you have to remember in isobaric process. Okay, pressure is constant, dq, du, dw is present, and also dq is equal to du plus dw, and also dw is equals to P into V2 minus V1, or nR into T2 minus T1. Also, we can take it as what, as I told, du by dq is equal to 1 by gamma, and dw by dq is equals to, we can take 1 minus 1 by gamma. This is for isobaric process. Now we come to isochoric process. In isochoric process, then which one is constant? Volume is constant. Isochoric process, volume is constant, and also as volume is constant, work done is zero. dw is zero. Once dw is zero, you know that dq is equal to du plus dw. As dw is zero, dq is equals to, we can take it as what? du. Okay. So whenever, so temperature increases, dq becomes what? Zero. When temperature increases, so what, this is an amount of heat is given to the system. Or if the amount of heat is given to the system, dq becomes positive. Once dq is positive, du becomes positive. du positive meaning is temperature increase in internal energy, or its temperature increases if you give the amount of heat to the system. If the amount of heat is given out from the system, or so we are taking out from the system, as dq is negative, if you take out amount of heat to the system, then du becomes negative. As du becomes negative, then temperature decreases. It becomes what? Cooled. Okay, these things you have to remember in isochoric process. Okay, right. Now we come to, this is the isochoric process, and another point you have to remember, very important, that is, so isochoric, isobaric, and also we can take, so let us take what here? Adiabatic, before adiabatic process, and after that is what? Isothermal. Okay. In adiabatic process, which one? So amount of heat is constant. As amount of heat is constant, dq becomes zero. So, and also pressure, volume, temperature, all the three are present. We can take it as what? PV to the power of gamma is constant in adiabatic process. And adiabatic process, sudden process. Whenever in the question, if it is given suddenly, it is used the word, which is nothing but adiabatic process. So this is q is constant and dq is zero. Okay, then we can take it as what? This is dq is zero means what? dw is equal to minus of du. Okay, that we can take in this, or we can write it as what du is equal to minus of dw. Suppose work done by the system, as work is done by the system, dw is positive. Once it is positive into negative is negative, du is negative. That's why its temperature decreases, it is cooled. Okay, like that you have to remember. Okay, next one, another adiabatic process. This is dq is equal to 0 and dw is equal to minus of du. And we can write it as what? What about the work done? dw is equals to, we know very well, what is the expression we wrote previously in previous slide? I told already. So what about du expression? Du is equals to, I gave nr into T2 minus T1 by gamma minus 1. I gave this one is what? nr into T2 minus T1 by gamma minus 1. I gave for du I gave. Now let us come to what about dw? dw is equals to minus of du. What is du is given? nr into T2 minus T1 by minus, if you multiply, it should be what? 1 minus gamma. Then we can write it as what? nr into T2 minus T1 by 1 minus gamma. This is for dw in adiabatic process. In adiabatic process, you should have to remember what dw is this one. So d is equal minus of dw and dq becomes what? 0. And also we can take in adiabatic process pv to the power of constant. Pv to the power of gamma is constant, or P1 V1 to the power of gamma is equals to P2 V2 to the power of gamma, and also T1 V1 to the power of gamma minus 1 is equal to T2 V2 to the power of gamma minus 1 we can write. Okay, so like that you can remember. Even so, pressure and temperature relation also we can take what? In this T1 to the power of gamma into P1 to the power of, so 1 minus gamma is constant, or if you don't know, then simply we can take what? From ideal gas equation we can take this relation. For example, if you want to know the TP relation or TV relation, only what you have to remember, need not remember that the relation. If you remember this one, for example, PV to the power of constant. If you know this one in adiabatic process, PV to the power of gamma is constant. If I am asking what is the relation between TP, so then what is the relation between temperature and pressure? We use the relation of ideal gas equation, which is equal to PV is equal to nRT. Then from this we want a TP relation, okay, or if you want to know the TV relation, so we have to get what? TV relation, like that also. That also, if you remember, you can so remember this formula, or you can get from this. So let us take what TP relation. PV is equal to nRT. We want T and P. V should not be there. Wherever V is there, nRT by P we can write. If I substitute here, we get nRT by P, so to the power of gamma, or simply, so 1 minus gamma, this is what gamma, and T power gamma is constant we get. Even we can take, so like this also we can remember T power gamma into P power 1 minus gamma is constant. This is the relation between PV and also TV and also TP relation we can get in adiabatic process. In isothermal process, PV is equals to constant. One last one we have to remember, that is isothermal. So in this isothermal process, then which one is constant? Temperature. Therefore, du becomes 0. Then dq is equals to what we can write? As du 0, dq is equals to dw. Then what about the work done in isothermal process? So work done is equals to, we can write, so 2.303 nRT log to the base 10 V2 by V1 we can write. Okay. Suppose if you are log to the base E, you write, so nRT log to the base E into V2 by V1, you need not write 2.303. So or we can write as what? 2.303 nRT log to the base 10, so P1 by P2. We know that, so pressure and volume is constant. P into V is constant. That's why it is inversely relation. Instead of writing V2 by V1, I can take what? P1 by P2. This is for isothermal process. Okay. So this you have to remember in isothermal process, this one. And in isobaric process, so this is about, you have to remember in this. And isothermal process, as the temperature is constant, so we can take it as what dq is equals to ns into dt we can get. As dq is 0, s is 0, specific heat is 0 we can take, and here is what specific heat is infinite we can write, because c is equal to dq by n dt. As dt is 0, then specific heat is infinite in the isothermal process, but in isobaric process it is specific heat is 0 we can say. This is what infinite. Okay, these things must have to remember before I go to discuss this question. These things should have to remember. Okay, once you go through this one, so then after that we discuss this question. Right. Now, let us come to this question. Before going, this one is what? Before, so to discuss this question, you should have to remember whatever the things I discussed, I wrote on this slide, should have to remember before. So if you want to do this question, you should have to remember all these things. First, I erase this one. So yes. Now, let us take, we can, this one, uh, right. Right. Now, let us do this question. So we discuss this question now. So let us take an ideal gas is taken through the cycle A to B, B to C, C to A, as shown in the figure. If the net heat supplied to the gas in the cycle is 5 joules, what is the work done by the gas in the process C to A? You should have to remember one very important. What is asking? Work done by the gas in the whole process is not asking. Work done by the gas in A to B, B to C, C to A is not asking. Only C to A is asking. Okay, that you have to remember, otherwise you do mistake. So now let us come to this question. So dq is equal to du plus dw. So this total means what? Which one? A to B, B to C, C to A. It is a cyclic. And also this one is also A to B, B to C, C to D, and A to B, B C D I am writing, which means that A to B, B to C, C to an ideal gas is taken through the cycle, this one as shown in the figure. If the net heat supplied to the gas in the cycle is, in this complete cycle, how much is supplied? Heat supplied. So heat is given means what? You have to take what? Positive heat is taken out from that is what? Negative. That's why it is what? Plus 5 joules. This is, should be careful about units. If it is given calories, you must have to convert into joules. If the answer is given in joules, of course. Let us see. But anyhow, it is given Newton per meter square, and this is what given in meter cube. Okay. So which should be equal to, is it cyclic process or not? Yes, it is a cyclic process. A to B, B to C, C to A. Again come to same position. So once if it comes to what? Same position, it comes to the same position. As I told, du becomes what? 0. One very important 2 points you have to remember. Cyclic process du 0, and in free expansion, so it is du 0, dq 0, dw 0. Okay, these 2 points should have to remember. Of course, anyhow, this is 0. Then dw is what? A to B, B to C, C to D. There are what? So he's not asking. Some students what they remember, you know. So what about dw? Simply they give the answer dw as what? Plus 5 joules, which is wrong. Why? He's not asking what for complete cycle is not asking. Only is asking C to A only is asking. Okay. That's why this answer also, so it will be there in the options 5 joule plus 5 joule, but that is not the correct one because he's not asking for the total. If we ask for total, that is only the answer, but he's asking particular. So C to A only. That means dw is equal to, so dw is nothing but A to B, B to C, C to D, which is equal to plus 5 is given. But he's asking about dw of A to B, C to A particular is asking. But this contains, so dw of A to B and also dw of B to C and also dw of C to A, which should be equal to total 5 joules. Then, so dW of A to B. So dW of A to B. A to B is what type of process is this? Isobaric. Once if it is what? Isobaric. What is the formula for isobaric? Isobaric is P into V2 minus V1. This is what isobaric process work done. So I'm just what writing. So P into V, this is what A to B, P into V2 minus V1, which should be equal to P is how much here? 10. So, but units you should have to remember, that is what should have to carefully, you have to observe. This is what Newton per meter square. Very good. It is given in SI system. And also volume is also given in meter cube. No problem at all. Need not to convert. So that means what A to B, final minus initial, 2 minus 1, 1, which should be equal to plus 10. So this should be equal to plus 10 is there. This one plus. What about B to C? B to C is what type of process? Volume is constant. As volume is constant, so it is isochoric process. In isochoric process, work done is 0. Therefore, this is 0. And dW of C to A we have, which should be equal to plus 5 joules we have. Then, now we can write as well dW of C to A should be equal to 5 joules plus 5 joules minus of. So plus 10 if you take into that side minus 10, which should be equal to C to A minus 5 joules. Therefore, the correct answer is minus 5, but it's not plus 5. So in the options they give plus they give and also minus they give, but the correct answer is minus 5 joules is the correct answer because only C to A is asking. Okay, so just go through this. We'll go to the next question. Right. Next, we go to the next one. Let us take, so one important point, one more. Let us take, what is the, this one is the simple, is the net. So area of PV graph gives which one? Area of PV graph gives work done. Area of PV graph gives work done. But if it is what? Cyclic process, we take it as what? Positive. And this is what? So cyclic is positive. We have to take what? This one. Okay. So not cyclic. This is what? Clockwise we take it as what? So it is what? Clockwise it is what? Positive. Anti-clockwise we take it as what? Negative. But here, so this one is what? Clockwise. This is what? This is clockwise and this is. So clockwise, this is what? Clockwise. For clockwise we take it as what? Positive. Anti-clockwise is negative. But clockwise area is less, but anti-clockwise area is more. That's why. So this is what? Plus is what? Less and minus is what? More. If you add, it becomes what? Negative. That's why what we get? So the total becomes what? Negative you get. Area of PV graph gives work done. Okay, these things you have to remember. For example, if I ask the question P and V, so let us take what this is. So this is P, this is 3P, and this is V, and this one is what? 4V is given. Let us take. Is this clockwise and anti-clockwise? Anti-clockwise. As it is anti-clockwise, you can take it as what? Negative. Clockwise is what? Positive. So then we can take it what? 3P minus area of this PV graph gives only PV graph, not PT, not VT, only PV graph. Area of PV graph, we can take it as what? Work done. So this is 2P, and also this one is what? 3V. Total becomes what? So this is what? 2P into 3V becomes what? 6PV. As it is what? So this one is what? Anti-clockwise. We take it as what? Negative. Okay. So like that you have to, so remember this one is work done. And before we discuss, so this one, the next question, just go through this and we'll finish this one by taking what? One question we'll take. Okay. After this. Right. Another thing you have to remember, one point let us take in this. So this one also very, very important. Now, so whenever the PV graph, so whose work done is what more? One thing you have to remember, let us take. So in this, area of PV graph gives work done, and so whose slope is more? So that is what adiabatic. So adiabatic slope of adiabatic is gamma times of slope of isothermal. Adiabatic slope is more, isothermal slope is less. Okay. Now we come to this is expansion. So the graph of expansion graph, let us take what this is what expansion. So once if it is what expanding, the area of just now I told. Okay. So then previous slide I told area of PV graph gives work done. Therefore, this is what area. This area gives what work done. This complete. So whose work done is more? This is what isobaric. Isobaric work done is more. This is what isobaric work done is more. Then whose slope is what more? In this, let us take what there are what two are there. One is this one is this one. So whose so slope is more? Slope is what more this one. So this slope is what more means what it should be what it is adiabatic. Adiabatic is the area is less, but isothermal area is more. That's why this is what isothermal area. Then after that is what adiabatic. That's why in expansion, whose work done is more? So isobaric work done is more. After that is what isothermal, and slope is more means what it is adiabatic. That's why. So this this one relation you have to remember. Isobaric process work done is more. Then after that isothermal. Then after that adiabatic. Then now we come to, so let us take what it is contraction. That is, so in this, so this is for expansion. So whenever it is what volume is decreasing in contraction, let us take what in this. So whose slope is what more? This is what slope is what more for which one? Adiabatic. Adiabatic slope is more than isothermal, then isobaric. So this work done is what more? That means what? Adiabatic work done more than isothermal, then isobaric. Okay. So, but in contraction, what you have to remember? Adiabatic is what more work done, then isothermal, then isobaric. These things you have to remember. This is what one important. So, and just to this one is what go through the all the work done and also different types of process. So go through that. So then you can do the questions in this chapter. Okay. So then all the best. So then just to go through this one, you will definitely you will get, you can attempt the questions, right? All the best.